Hello, my name is Mohammad Nadeem from Mechanical Engineering. My CEP on basics of 3D geometric modeling. Basics of 3D geometric modeling. A concise visual exploration of how geometry becomes digital from points to printable objects. This deck covers fundamentals, workflows, math foundations, common model types, validation, and future directions. What is 3D geometric modeling? 3D geometric modeling is the art of science of creating precise digital presentations of objects with three dimensions: height, width, and depth. It enables visualization, editing, and analysis for engineering, architecture, animation, and manufacturing. Emphasis color used consistently for Asians throughout the deck. Core elements of 3D models: building blocks, vertices, edges, polygons. Vertices, discrete points in 3D space. Straight connections between vertices. Surface, triangles, quads formed by edges. Combine these two meshes, surface patches or solids. Basic geometric shapes primitives has three: cube, sphere, cylinder. In cube, common starting block for buildings, boxes, and modular pots. Sphere, useful for organic forms, bearings, and rounded details. Cylinder, ideal for columns, pipes, and rotational parts. This cube, sphere, cylinder are the basic geometric shapes of primitives. Types of geometric models: wireframe, surface, and solid. Wireframe, edges and vertices only. Quick visual skeleton with minimal data, great for concept and topology checks. Surface defines outer surfaces without interior for rendering and aerodynamic studies. Solid full volume representation, Boolean ops, mass properties, and manufacturing workflows. Mathematical foundations: 3D modeling relies on points, vectors, and parametric curves. Bezier, B-splines, NURBS, transportations, translation, rotation, scaling are applied matrices. Parametric equations give precise control over curves and surfaces. Vectors and coordinates: first, represent position, and direction in 3D space X, Y, Z. In second, curves and surfaces Bezier, B-spline parametrizations for smooth forms. In third, transforms matrix math for moving and orienting geometry reliably. How 3D models are created. Workflow. First, concept and sketch are important reference. Second, creative primitives or sketch profiles. Third, modeling, mesh, editing, subdivision or NURBS surfacing. Fourth, refine topology, UVs and normals for rendering or fabrication. Fifth, export formats for simulation, 3D printing or game engines. Popular tools Autodesk Fusion 360, Blender, Tinkercad, pick based on purpose, CAD versus sculpting versus education. Applications models where models come alive in engineering, architecture, animation and gaming and 3D printing. In engineering, parts assemblies, tolerance analysis and virtual testing before manufacture. Architecture, scaled models and virtual walkthroughs to validate form, light and space. Animation and gaming. In animation and gaming, characters and environments and assets optimized for performance and aesthetics in the gaming environment, and also in 3D printing, digital blueprints converted into physical objects with attention to watertight solids and printability. Challenges and validation. Models must be precise and unambiguous. Common issues include non-manifold edges, holes in meshes, inconsistent normals and self-intersections. Validation steps ensure models are watertight, correctly scaled, and manufacturable. Efficient data structures and algorithms. Example BSP trees of edge mesh are crucial for complex scenes. Check for holes and flipped normals, simplify meshes without losing critical detail. Run Boolean tests and collision and simulation checks. The future of 3D geometric modeling. AI-driven design, real-time simulation versus VR, industry impact, India, AI-driven design, automated optimization, generative design, and faster iteration cycles. Real-time simulation versus VR, immersive validation and collaborative design review in real time. Industry impact India, growth across manufacturing, education, and entertainment, accessible tools democratize innovation. Start exploring modeling tools, practice topology and validation and experiment with AI assisted workflows. The next innovations are built from geometric foundations. Thank you.